Alright gents, this is my third crack at doing these videos. Hopefully it's a little bit more entertaining than the previous ones, which I reckon have been pretty boring. So, the next topic we're going to focus on is the second and higher derivatives. In fact, you can continue to derive a function however many times. In the Tunic course, we only really want you to derive it once or twice. You can do higher derivatives, as the heading there says, but only once or twice is really all we want. Yeah, so I've gone to uni and did I think triple differentiation, but really it's not required in the Tunic course. So I've gone through the first derivative with you guys in the prelim course. I'm going to go through the second derivative here, and I'm just going to show you with this lovely new arrows I've just worked out. Oh, that way, please. That that's the notation that they use. So that's the notation there. Also, that's the notation. That's the most common one used. I've never seen that one there, so don't worry about that one. And Mr. Candy will not allow this, so don't worry about those ones. So that one there and that one there, the two ones that are circled, are the two notations that we use. Otherwise, please ignore the rest. So we're going to do further development of the second derivative mainly. It's quite important when you talk about concavity, and it will make determining the nature of stationary points easier because you can just use the second derivative. Okay, all of a sudden you'll see that down the bottom there a worked example has appeared, sorry, at the top there where it says find the successive derivatives of y equals x to the power of 4 plus x to the power of 3 plus x to the power of 2 plus x plus 1. If you understand this worked example that I'm going to guide you through, then that's all you really need to know. So the successive derivatives. So you can derive the first one as so. So we'll do f dash x. If you derive that, it will equal 4x cubed plus 3x squared plus 2x plus 1. Alright. And that is known as the first derivative as you've derived it once. I know it's pretty crazy, but that's how it works. If you derive it a second time, it's known as the second derivative, and that is the notation there. So to find the second derivative, you derive the first derivative again. So 4x cubed when derived will become 12x squared plus, well, 3x squared when derived will become 6x plus, and then you just do plus 2. So that's known as the second derivative. If you want to derive it again, you can. Alright, so if you derive the second derivative, believe it or not, you're up to the third derivative. And the notation is like that. So then you derive the second one, so 12x squared derived will be 24x plus 6. Alright, and you can continue. Once you derive the third derivative, you then derive... Now, I'm not sure if this is the notation, but we'll give it a crack. We'll stick with the Roman numeral side, eh? I don't know if that's right, so don't take that as the mathematical Bible there. So, deriving the third one, so deriving 24x becomes 24. Alright, you cannot derive that again, well, it'll just be 0, and then from there on, it'll be 0. But there's certain functions that you can continue to derive for the rest of your life. Alright, and that's all that I wanted to get across here, that there is the notion of the first derivative, there is also the second derivative, third, fourth, fifth, and so forth. But in the Tunic course, we're just going to focus on the first or second. Okay, please come in with any questions. I'm going to get you to watch a second video, and we'll do some work during class.